Let me start you off.
Okay.
And then, but yeah, the second half of class, I'll let you go back. Okay, so let's start off looking at page 25. Okay, since identify variable, create system equation, write matrix equation, and solve. Show work for solving a 2x2 matrix equation. You may use technology to solve any work involving 3x3 matrix equations. So for if it's a 2x2 matrix, you're more than welcome to use your calculator, but I do want to see your work in terms of creating your inverse and setting up to do your multiplication steps. Okay. All right, so number one says one group of people purchased 10 hot dogs and 5 soft drinks at a cost of $8.75. A second group bought 7 hot dogs and 4 soft drinks at a cost of $6.25. What is the cost of a single hot dog and a single soft drink? So we always like to start off with that last sentence. That last sentence is going to kind of help you decide how you're going to define your variables. And I like to use X and Y. Okay. So we're asking for a single hot dog and single soft drink costs. So we can say X equals what? What can X represent? Okay, so cost, right? So cost per hot dog. And Y would be the cost per soft drink. Okay. So now we can start building our equation. The first sentence can be used to build the first equation, and the second sentence can be used to build the second equation. So 10 hot dogs and 5 soft drinks totals out to be $8.75. What equation can we come out of that? Yep. All right, we know that 10 hot dogs at the cost per hot dog plus 5 soft drinks at the cost per soft drink. If I total that up, that will give me the that $8.75. Okay, what's our second equation? Mm-hmm. Right, so now we can create a 2x2 matrix, coefficient matrix. Okay, before you go to your calculator, I do want us to practice building the inverse. So what has to come over to the other side?
10, 5, 2.
Yeah, that's right, that 2x2 matrix. Okay, so this requires an inverse. So I want to see that we still remember how to do inverse. So inverse is 1 over the determinant, swap the A and D, and then the B and C changes signs. So let's find the determinant, AD minus BC.
Like have a strong determinant for the word problems, or like after we just.
You can solve using the calculator, but I want to see the steps that you can actually build the determinant, build the inverse by hand. Okay, but obviously you can do everything with calculator. But here you're going to have to show your work. Show me that that I can follow your steps, and show me like as if you were doing it without a calculator. But obviously you can use your calculator to do all the steps. Okay, so determinant AD minus BC. What is that equal to? What's our determinant? Yeah, determinant is 40 minus 35, which is 5. Right. 10 times 4 is 40, minus 5 times 7, 35. So XY equals the determinants 1/5. And then I gotta flip my A, B, and B, C, right? 10 and 4 swap places. 7 and 5 changes signs. Okay. Show your multiplication steps. And then I can multiply the 1/5 at the end. Four times 8.25 plus -5 times 6.25. -7 times 8.25 plus 10 times 6.25. And after everything is done, we're going to multiply all this by what? 1/5. Yep. So I would save this to the end, multiply those fractions out, then multiply the the matrices out, then multiply by 1/5. And you'll get the same answer as if you were to enter all this in the calculator and do a 2x2 inverse matrix times or 2x1 matrix. Okay, any questions with number 1? Okay, so therefore, 75 cents is the cost of one hot dog, 25 cents is the cost per soft drink. Okay, number 2, 4 large cheeseburger and 2 chocolate milkshakes cost a total of $7.90. 2 milkshakes cost 15 cents more than 1 cheeseburger. What is the cost of a cheeseburger and what is the cost of a milkshake? So we know what we're looking for. X is cost per cheeseburger, Y is cost per milkshake. Okay, so the first equation is pretty straightforward. How can I build that? 4 large cheeseburgers and 2 milkshakes equals $7.90. Okay, what could be a little more challenging is the second sentence here. 2 milkshakes cost $15 more than a cheeseburger. What I shared with 4 Period yesterday is that sometimes if you're able to take one of these more challenging relationships, and if you can rethink, or if you can think of it as, if you can reword it using the word is, then that sometimes is able to kind of help you see that relationship better. So for instance, a problem that we saw from last Friday is she purchased 10 more pounds of dog food than birdseed. And this is really saying the amount of dog food is 10 more than the amount of birdseed. Okay, so we want to put that 10 with the birdseed and not with the dog food, because if we want to make an equivalent equation, we have to understand that there's less of the birdseed, so I need to add 10 to the birdseed in order to make the two sides equal. So same thing here. 2 milkshakes is cost 15 cents more than 1 cheeseburger. So we can think of it this way, that 2 milkshakes. Okay, so this one is set up, I think, more easily for us. We can say 2 milkshakes is 15 cents more than cheeseburger. So this one is a little bit easier for us to manage. We can say 2y is equal to 15 cents more than a cheeseburger. So 1x plus 0.15. We know that if we take a cheeseburger and if we add 15 cents to it, that's going to be equivalent to 2 milkshakes. So how can I rewrite this equation so that I can make it fit where the x's and y's need to go? Okay, from here we can build the coefficient, variable, and the constant matrix. Okay, so I feel those are the same. Okay, so why don't we save this for the end? Let's see if we can get through all the setups for all the problems. I think that's the hard part, right? That's the part we need help with. So let's put this on pause, come back to it, and let's go to number 3. Okay, because from here it's the same process every time. Okay, number 3. Thompson's furniture store borrowed $650,000 to expand its facilities and extend its product line. Some of the money borrowed at 4%, some at 6.5%, and the rest at 9%. How much was borrowed at each rate if the annual interest was $46,000 and the amount borrowed at 9% was twice the amount borrowed at 4%? Okay, so that's what we're looking for. We're looking for how much was borrowed at each rate. So we'll let x, how many variables are we going to have here? 3, okay. So we'll let x be the amount borrowed at 4%. Okay, y is the amount borrowed at 6.5%. And then z is the amount borrowed at 9%. Okay, so if we have 3 variables, that means we need to build 3 equations. So what's an easy equation that we can start off with? It's the amount borrowed though. So the amount borrowed needs to add up to be what? 650, yeah. The interest rate is what's returned back to you. That's the 46,000. That's the set that we use that second equation involving the percentages. Okay, but we know that however much you put into each account, we know that they are all going to add up to 650,000. So we want the interest to be 46,000. So that means how much is returned to you based off of what the percentage that's returned to you. So how can we use the second equation involving the percentages here? Yeah, every percentage is going to be turned into a decimal. And the way you do that is you move the decimal over twice. Okay, so 0.04 x plus what? Point, yeah, 0.065y plus 0.09z. Okay, third equation, sometimes that can be challenging, but I think this one is a little more straightforward. The amount borrowed was or is twice the amount borrowed at 4%. So having that word was is nice because you know that everything that you see is going to be nicely set up for you. So the amount borrowed at 9%, what's that variable? Z. So Z was, so when I see the word was or is, I know I can put an equal sign there. Twice the amount borrowed at 4%. 2x, yeah. So if I double the amount of what I borrowed at 4%, that's going to be equivalent to what I borrowed at 9%. So 2x equals z. So how can I rewrite a different version of this equation that will fit the pattern that I want? 2x plus 0y minus 1z equals 0. Yeah. Yeah, I like to put a 1 there so that way you can see it more clearly. So then you'll create 3 by, so this one we can go directly to the calculator, right? Once we have our relationship here. So we know that there's a coefficient matrix here. We bring this over to the right side. XYZ equals inverse of matrix, the 3 by 3 matrix times that 3 by 1 matrix. So in your calculator, you're going to create matrix A, you'll create matrix B, and then fill in all your values for your matrix A and B, and then you're going to do inverse of matrix A times B. And I'll come around and help you out if you're having trouble with your calculator, but I want to just see if we can get all the setup on paper and then either working out by hand or calculator work. We can do that second half of class. Okay, I'll also show the answers for each of these once we have a chance to try the setup for each problem. Okay, number 4. At the Pittsburgh Zoo, children ride a train for 25 cents. Adult pays $1, senior citizen 75 cents. On a given day, 1,400 passengers paid a total of $740. There were 250 more children riders than all the other riders. Find the number of children, adult, and senior riders. Okay, so I like to use that last sentence to help me build or to assign what I'm looking for. How many variables? So this one is not cost, right? This is the number of children, number of adults, number of senior riders. Okay, let's have an equation that is just related to the number of passengers and then the other equation involving the amount. So what equation can I use involving the 1,400? If I add up all the number of riders, they must total to be 1,400, right? And now the $740, we know that's going to involve the cost per rider. So how can we involve the 25 cents, a dollar, and the 75 cents with the second equation? We have to write it as a decimal, right? 25 cents is what? 0.25. So however many children there are, we're gonna be charging them 25 cents per head plus what's next? Plus what? Plus 1y, a dollar per adult, plus 0.75z, and that's gonna be $740. All right, this one, we have to be careful with this third sentence here. There were 250 more children riders than all the other riders. So this is going to involve a relationship between X, Y, and Z, and also we got to put in 250s there somewhere. 250 more children riders than all the other riders. Good. X equals, right? Because I know I can add up adults and seniors plus 250 in order to get that number to be equal to number of children because there's so many children, right? So what? X equals Y plus Z plus 250. Okay, so an equation that I can rewrite to fit the pattern that I want. 1x what? Minus 1y minus 1z equals 250. Okay. All right, so continue working on this worksheet. We'll see if we can get through 5 through 8. Whatever we don't finish, we can continue tomorrow. But I want to, I'll put the solutions up for the setup for 5 through 8 in a second. But at least I want to come around and just see if you can let me know what class you want to take.
Yes. We're all doing.
I can use my calculator.
Yes, yeah, you can calculate for everything, but I'll be asking for show your work for 2x2.
You guys made. Yeah, so every time you put that. Are you doing AB? You're gonna make the Super Bowl one, dude. Like AB. We are, that's what I'm telling you. You're not taking it. That's better. That great, really? Thanks, geometry.
Yeah.
But like, great things, geometry. It's like, it's like if you other. Like, it's now that you're on the. Yeah, that's why you.
I turned in the thing on Friday.
Seconds.
Ian's in the second period. Friday, first, second period. His name is not right.
I think it's on the day of the line. It's not. I know for a fact there's no age. I just know.
We can leave the five. He said that he has to pretty quickly and then we can ask him.
Yes.
You just have to pay for it yourself.
That could be pretty nice.
Just an extra AP or
Just give you an extra class.
are you gonna take one if you like how it's for the show? Yeah, like not this different next year. It's like, you know what I'm saying? It's the same. There's an AP next year. So, but like, you always register as something for income and stuff. I would like this class. I won't ask him. I told.
Why not?
It's the same thing. Yeah. I feel like this year you have a conference, so that's good. No, don't retake this time.
I'm not going to. At one point, I was like, what do you retake? I wrote the explanation.
Oh, I have.
But you got the campaign.
Right.
No, that's not.
No, I have.
Yeah.
No, I studied more. I'm gonna get a certification for it, or I would certainly.
Yes, well, the review is in the packet, but I'll give you another review. That you need to say guys.
Next page? Yeah. That's nice.
Oh.
Why would you do like that?
I don't think I have a new number.
I know that's. But it's just like that.
Yeah.
No way, your house is too. It wasn't in my house, so. Oh, because I had that. I didn't even solve the one, but yeah, like I just told these, never gonna study one. I never. That guy.
Well, it could be me then. It could be me, like 20 years. Part of the house.
Oh, it's not, I love it.
Because I'm not.
Died though. We got
It's good to say. Eight instead of make them eight.
Exactly.
I don't even know working up to it.
What is that?
That is kind of a yeah.
You know what's trying this? What is not the same as now? I heard you. 40, 22, yeah. What is like this? Well, so I think I'll keep saying. That's what I think.
Was the one I had to
Like, they want to sign it.
Oh, no.
No, if they do it like that, they should put Ash like.
They changed the thing.
Not from the library. Jack, no, for the live stuff. For the live, like, yeah. But honestly, there's the back.
Yes, I did know that. You know what I.
Yeah.
That's another. Well, the PhD one is.
I